whenever you have certain simultaneous linear equations to solve, whenever the solution exists, it is called as consistent, and if the solution does not exist, it is called as inconsistent. Finding the solution of system of linear equation is called as matrix method. Whenever the determinant value is not equal to 0, clearly the system of linear equation is consistent and it has only one solution, that is, the solution is unique. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are at the last session of the chapter Determinants, and in this session we are going to learn a very important method of solving linear equation, that is a matrix method, and it is one of the applications of determinants and matrices. So what is this matrix method? It is very helpful to solve a simultaneous linear equation to find out the unknown variables x, y, z. So let's start it now. Here we have the application of determinants and matrices. So we have two types of systems here. So one is consistent system, another one is inconsistent system. What is this consistent system? A system of equations is said to be consistent if its solution exists. So whenever the solution exists, we call it as a consistent system. The solution may be one or more or infinitely many solutions. And what is inconsistent system? Here, whenever the system of equation is said to be inconsistent if its solution does not exist. Whenever you have certain simultaneous linear equations to solve, whenever the solution exists, it is called as consistent, and if the solution does not exist, it is called as inconsistent. Now here, to say the linear equation or to find its inverse or to find out the existence of the solution, so here we have, if A is a non-singular matrix, then only inverse exists. This one we have already known. So here we are going to solve the system of linear equation by finding the inverse of the matrix. To find the unknown values of the system of linear equation, we are going to use the inverse of a matrix, and hence this method of finding the solution of system of linear equation is called as matrix method. Now, here, if A is singular matrix, so when we are supposed to say the matrix have a solution, that is only when it is non-singular and A inverse exists. But suppose if it is a singular, then we have two more subcases. Then we are supposed to find out adjoint A into B. So here, to find the system of linear equation, here we have X, matrix A, matrix B, where X is the unknown variables x, y, z. A is the coefficients of the variables x, y, z, and B is the constant equator. So here to solve it, we need x is equal to A inverse B. Now here, suppose it is singular matrix, then determinant A will be clearly 0. Then how to find out the solution? We have to find out adjoint A into B. If adjoint A into B is not equal to 0 or O we call it as, if it is not equal to null matrix, then the solution does not exist and the system of linear equation is called as inconsistent. If the solution does not exist, whenever you find adjoint A into B is not equal to 0, then we call it as inconsistent. If it is equal to null matrix, then either the system of linear equation is consistent or inconsistent according as the system have either infinitely many solution or it has only one solution. Now here we are going to examine the consistency or inconsistency of a given linear equations here. How to find it? Just find the value of the determinant is 0 or not. If it is non-singular, then it is clearly consistent. If it is singular, then we have to find out the number of solutions to say whether it is consistent or inconsistent. Now let's see here. So here is first question given, 2x minus y is equal to 5, x plus y is equal to 4. So matrix A is, as I said, it is only the coefficients of the variables. So what are the coefficients of variable? 2, minus 1, 1 and 1 here. Let's find out determinant A. 2 ones are 2 minus 1 into minus 1 minus 1. So clearly it is 3 not equal to 0. So therefore here the given system of linear equation given here is consistent and it has unique solution. Unique means one and only one solution. Next, 5x minus y plus 4z is equal to 5. 2x plus 3y plus 5z is equal to 2. 5x minus 2y plus 6z is equal to minus 1. Let's write the matrix A. Matrix A is the coefficients of the variable. 5, minus 1, 4, 2, 3, 5. Here 5 minus 2, 6. So let's find determinant A. We should expand it with the first row here. 5 into 3 6 are 18 minus 5 2s are minus 10 becomes plus 10. Next we have minus of minus 1 because second element is minus 1. So delete the row column containing minus 1. 2 6 are 12 minus 5 5s are 25. Next plus 4 into delete the row, delete the column. 2 into 2 is minus 4 and 5 3s are 15. So we have here 18 plus 10, 28. 28 into 5. So we have here 140. Minus 1 becomes plus 1. 12 minus 25 becomes minus 13. So minus 4 minus 15 is minus 19. Minus 19 into 4, minus 76. So this is equal to 51 and it is clearly not equal to 0. So whenever the determinant value is not equal to 0, clearly the system of linear equation is consistent and it has only one solution. That is, the solution is unique. Next is solve the system of linear equations given here. So here we are going to separate the matrices X, A, B. How we are going to separate it? Let's see here. So we are taking matrix A as the coefficients of X and Y. Here 2, 5, 3, 2. And matrix X is the variables used. So here the only variables used is X and Y. And matrix B is the constant equated, that is 1 and 7. So this is how we are going to write A, X, B. And to solve this system of equation, we use the formula X is equal to A inverse B. And A inverse is nothing but 1 over determinant A into adjoint A. Hence, we have to find out determinant A, adjoint A, then multiply the product to find the unknown values of X and Y. So, this is a very important question for 5 marks. And one question of matrix method will be in your question paper compulsorily. So, look at the method now. So, first for write A, write matrix X, write matrix B. Then we need to solve X is equal to A inverse B. To find A inverse, we need 1 over determinant A into adjoint A. So, first let us find out determinant A. Determinant A is 2 2s are 4 minus 5 3s are 15. So, the answer is minus 11 not equal to 0. If determinant A is not equal to 0, what does this implies? A inverse exists. Now, to find A inverse, we need adjoint A. And to find adjoint A for 2 cross 2 matrix, I have shown you the shortcut method. Interchange the principal diagonal element, change the sign of other diagonal. So, this is adjoint A. Now, let's write X is equal to A inverse B. So, X is equal to A inverse B. What is X? It is X and Y. What is A inverse B? 1 over determinant A. That is 1 over minus 11 and adjoint A. Adjoint A is 2 minus 5 minus 3, 2. 2 minus 5 minus 3, 2. And here we have B. What is matrix B? 1 and 7. Let's solve this. Let's keep this constant outside. Multiply this. 2 1s are 2 minus 7 5s are 35. Next minus 3 into 1 minus 3. 7 2s are 14. So, solving this, we have minus 1 by 11. So, here we get minus 33. So, 14 minus 3 is 11. So divide the equation by minus 11 only, because we have minus here. Divide the equation by minus 11. So then we get here 3 and minus 1. So here we have x and y. So clearly two matrices are equal, therefore x is equal to 3 and y is equal to minus 1. So this is a very important method to find out the solution for the system of linear equation, and this is called as matrix method. So it's a compulsory 5-mark question in your examination. So how we are going to find out? First we will separate the matrix A, X and B. We will find determinant A. If it is equal to 0, stop it. If it is not equal to 0, then A inverse exists. Find A inverse, use the formula X is equal to A inverse B, solve it and find the solution. Let's take one more question. 5x plus 2y is equal to 4, 7x plus 3y is equal to 5. So matrix A is 5, 2, 7, 3. And X is X and Y. And B is here 4 and 5. Let's find determinant A. 5 3s are 15, 7 2s are 14. So 1 not equal to 0. Therefore, A inverse exists. Now adjoint A. Adjoint A of 2 cross 2 is interchange 5 and 3. Change the sign, minus 2, minus 7. So therefore, A inverse is equal to 1 over determinant A into adjoint A. Since determinant A is 1, 1 by 1 is 1. So therefore, A inverse is 3 minus 2 minus 7, 5. Let's take the solution. X is equal to A inverse B. X is X and Y. A inverse is 3 minus 2 minus 7, 5. And B is 4, 5. Multiply this first row into first column. 3 4s are 12 minus 5 2s are 10. Next, minus 7 into 4. So minus 28 plus 25. So solving this, we have 2 here minus 3 here. So here we have x, y. So therefore the value of x is 2 and the value of y is minus 3. So this is how we are going to find the solution. So next question, 2x plus 3y plus 3z is equal to 5, x minus 2y plus z is equal to minus 4, 3x minus y minus 2z is equal to 3. So this is the equation given. Let's write matrix A. Matrix A is 3 cross 3 matrix, 2, 3, 3, 1, minus 2, 1, 3, minus 1, minus 2. Matrix X is X, Y, Z. And matrix B is 5, 4, 3. So first is to find out determinant A. In your examination, the question is asked only for 3 cross 3 matrices. That is, you have to find the solutions of X and Y for 3 cross 3 matrices. So these type of questions will be given. So which is very important for 5 marks. Now determinant A. So let me expand through first row. 2 into minus 2 becomes 4. Minus of minus 1 plus 1. Next, minus 3 into minus 2 minus 3. Next is plus 3 into, delete the row, delete the column. So we have minus 1 plus 6. So we have 5 to 10. So minus 5 minus 3 plus 15. Next we have 5 3s are 15. So clearly we have 40. So the value of the determinant A is 40, which is not equal to 0. Hence A inverse exists. Now for this we need to find out A inverse. To find A inverse we need adjoint. And to find adjoint of 3 cross 3 matrices here, we have to find the cofactors of the given matrix. So let's write matrix A now. So we have matrix A is equal to 2, 3, 3. 1 minus 2, 1. 3 minus 1 minus 2. Now let's find out A11, A12, A13 plus minus plus. So on solving this here we get 5, 5, 5 here. Next is A21, A22, A23. So here minus plus minus. So by finding the minus of particular row here, that is for 1, minus 2 and 1, we get the values as 3. So here we get minus 13 and here we get minus 11. So solving this, the value will become, so here it is minus 3, 3, minus 13 and 11. Next we have A31, A32, A33. So that is plus minus plus. So here we have 9. So minus 1 minus 7. So the value is 9, 1 minus 7. Now therefore adjoint A is here 5, 5, 5. So write in this order only, you will get directly adjoint A. So 3 minus 13, 11. And here we have 9, 1 minus 7. Now we can also write A inverse. So therefore, X is equal to A inverse into B. So this is X, Y, Z. We know this is 1 over determinant A into adjoint A into B. So here we have 1 over 40. Adjoint A is 5, 5, 5, 3 minus 13, 11, 9, 1 minus 7. And we need to write matrix B. And matrix B, we got it as 5, 4, 3. So let's solve this X, Y, Z. So here we have 1 by 40. Now let's multiply these two matrices. We have 5 5s are 25 minus 12 plus 27. Next is 25 plus 52 plus 3. Next 25 minus 44 minus 21. So here 1 by 40 is equal to, solving this we get here 40, 80 minus 40. And here you have X, Y, Z. Divide all the elements by 40. So this becomes 1, 2 minus 1. So clearly these two matrices are equal. So therefore we can write X is equal to 1, Y is equal to 2 and Z is equal to minus 1. So this is how we are going to solve the simultaneous linear equation by matrix method. Next, X minus Y plus 2Z is equal to 7. 3X plus 4Y minus 5Z is equal to minus 5. 2X minus Y plus 3Z is equal to 12. Let's write matrix A, 1, minus 1, 2. 3, 4, minus 5. 2, minus 1, 3. So this is matrix A. Let's write matrix X. So matrix X is X, Y, Z. Next, matrix B is 7, minus 5, 12. So next, we are going to find out the value of the determinant A. So it is expand through the first row here. So we have 1 into 4 3s are 12 minus 5, which becomes 5 only. Next is minus of minus 1. So 3 3s are 9 minus 10 becomes plus 10. Next we have plus 2, 2. So minus 3 minus 8. So we have 12 minus 5, 7. So 19, which becomes plus 19. And minus 3 minus 8 is minus 11. 2s are minus 22. So here we get determinant A is equal to 4, which is not equal to 0. Now, determinant A is not equal to 0 means A inverse exists. So, let's find A inverse. To find A inverse, we need adjoint A. So, let's write matrix A once again. Matrix A is equal to 1 minus 1, 2, 3, 4 minus 5, 2 minus 1, 3. So, let's write the cofactors A11, A12, A13. Plus, minus, plus. So, solving this, so we get the cofactors as 7, 19, and here we get minus 11. So, therefore, the answer here is 7, minus 19, minus 11. Next is A21, A22, A23. Minus, plus, minus. So, here we have minus 1. So, here also we have minus 1 and here we have 1. So, the answer is 1, minus 1, minus 1. Next, we have A31, A32, A33. So, the sign is plus, minus, plus. So, here we have minus 3, minus 11 and 7 here. So, the value is minus 3, 11, 7. Now, if you write this in the same order, it is equal to the adjoint of the given matrix. So, what is adjoint of a matrix now? 7 minus 19 minus 11, 1 minus 1 minus 1, and here we have minus 3, 11, and here we have 7. So, once you found adjoint A and determinant, you can use x is equal to A inverse B to solve the equation. So, we have x is equal to A inverse B. So, x is equal to 1 over determinant A into adjoint A into B. So, x is x, y, z. So, 1 over determinant is 1 divided by 4. Adjoint A is 7 minus 19 minus 11, 1 minus 1 minus 1, minus 3, 11, 7. So, this is adjoint A. And matrix B is 7 minus 5, 12. So, we have here x, y, z is equal to 1 by 4. So, we have here multiplying and solving this equation, we get the matrix as 8, 4, 12. After solving this, then divide each element by 4, we get 2, 1, 3. So, therefore, clearly x is equal to 2, y is equal to 1 and z is equal to 3. So, this is the solution. So, in this session, we have found the solution to system of linear equation by matrix method. I have already told you this is one of the important and compulsory question for 5 marks in your examination. This completes the chapter Determinants. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.